Work performance and work measurements, the stopwatch time study. Work measurements. So why are we going to use work measurements? The main reason to use a work measurement is to determine the average time it takes to do a job. There are times when we need to know how long it takes someone to complete a job and all of its elements. Are we going to use a time study? We're going to use it to determine the expected or average production rate per period of time. So how many units can a worker produce in an hour? Measurements for labor planning and budgeting. Say we have a worker who can produce 100 units a day, but we need 500 units per day. So if we do a work study and take work measurements, and we've determined that the worker can produce on average 100 units a day, we know that that one worker cannot produce the 500 required units. Actually going to have to hire 4 more employees. Budgeting. What's our labor cost? What's our labor cost percentage or portion of labor for producing a product? How much is our labor costing us per unit? Is the company making money off of its labor? These are things that time studies are useful for. So when is the appropriate time to do a time study? Time studies are best done if a motion study has already been completed and a best method has been established for doing a job and all of its elements. Where are you going to use a time study? Time studies are used when there's highly repetitive motion in a job, like in a pizza kitchen where the production is highly repetitive. The worker is constantly picking up and setting down ingredients on top of the pizza dough. Let's go over the process of a stopwatch time study. On the screen, you'll see a time study observation sheet. Again, in the process, we have to establish a standard job method using a motion study. In the observation sheet, you will see the elements broken down on the left-hand side. In this particular case, we have 4 different elements. Elements should be broken down into micro activities with definite breaking points. Points can be determined by a specific motion. In this case, it would be grasping something, grasping it with your hand, picking it up, and setting it down. After breaking down the elements of the job, we're going to have to do the study. So you're going to have to go in and observe an employee or employees doing a particular job and how much time it takes for each element. And the time for each element will go in the row with the lowercase t, and then a run time for that cycle, which is represented by the 1 through 10. The run time will go underneath each element's time. So in this observation sheet, what you can see is element 1 in cycle 1 takes 0.04 minutes. Element 2 takes 0.07 minutes. And the runtime is totaled for element 1 and element 2 under cycle 1. The runtime goes from cycle 1, element 1, through cycle 10, element 4. In the sandwich assembly example that we have here, we're going to run through 10 cycles. At the end of each element, we're going to compute an average time for that element, so we can determine how long it takes, or on average, how long it takes to complete that element. As an observer, you're going to have to determine the worker's performance. Was the worker performing at a higher than normal rate? Was the employee performing at a slower rate? Sometimes workers are intimidated and change their work performance when they know they're being observed. So we have to be familiar with the normal rate. So it's difficult to just walk into a job fresh and not know the employee or not know something about the task itself. And in the end of the chart, or in the end of the row, we're going to have to compute the normal element time, typically just called the normal time. And in this process, we're going to have to compute the normal cycle time, which we will go over in just a minute. And we will also have to compute the standard cycle time. Let's calculate the average element time, which is the T-bar. So what we're going to do is we're going to have T-bar equals the sum of T, which is all of our element times through all 10 cycles, the sum of that, divided by the number of cycles. So we're going to sum up all of the elements that are in orange, and we're going to get 0.53. And then we're going to take that and divide it by the number of cycles, which is 10. And that gives us 0.053. This is the average time it takes this particular worker to complete element 1. Now let's look at the normal element time, or the normal time. So normal time is represented by an uppercase N and a lowercase t. So we have NT equals T bar, which is the average time, multiplied times the rate of the worker's performance. And the rate of the worker's performance is going to vary from element to element. So for us, we're going to take and multiply our average time, which is 0.053, and we're going to multiply it by the determined rate of worker performance of 1.05, and this is going to give us our normal time of 0.056. So if you have a rate of worker performance over 1, we're assuming that the worker was actually working faster because they knew they were observed. Let's continue on with our normal cycle time. So to calculate our normal cycle time, which is represented by an uppercase N, uppercase T, we're going to sum all of the normal times for the elements. So in this case, we're going to go down the right-hand column under N lowercase t. And when we do that, we get a normal cycle time of 0.387. So what this means is that on average, it takes 0.387 minutes to assemble a sandwich. Let's look at standard time. Standard time is represented by an uppercase S and an uppercase T, and it is equal to our normal time multiplied by 1 plus an allowance factor. The allowance factor is all of the normal, unavoidable delays that workers have during the course of work. Going to the restroom, fatigue, anything that would affect their rate, phone call. The allowance factor is similar to the rating factor, or the performance rating factor that we used earlier in our calculations to determine whether or not an employee was working faster or slower because they were being observed. Meaning that this is something that the observer will have to, or that the company will have to determine on average how much time during the workday is taken out or interrupted for going to the restroom or personal needs. So in our sandwich assembly example that we have here, we're going to take our normal cycle time and multiply it times an allowance factor of 0.15 plus 1, of course. So we're taking the 1 plus 0.15, with the 0.15 is our allowance factor. We're going to take that and multiply it times the 0.387. So now we're going to get a standard time to go through one cycle of 0.445 minutes. Again, this is going to be our standard cycle time. This is a standard time to go through one cycle of a job, accounting for bathroom breaks and anything else that may interrupt a worker's day. So again, why do we want to use a time study? Remember, production rates. How many sandwiches can someone assemble in 4 hours? How much is our direct labor costing us per sandwich? So let's look at two quick examples here. So the 4-hour period, we have 60 minutes in an hour times 4. And then we're going to divide that by our standard time to determine how many sandwiches can be produced in a 4-hour period. So for our example here with the sandwich assembly, we get 539 sandwiches can be produced in a 4-hour period. How much is each sandwich costing us? Let's assume we're paying our employee $10 an hour. That $10 an hour times 4 is 40. So we're paying them $40 for working a 4-hour period. Then we're going to divide that by the 539 sandwiches. And then we're going to get $0.074 or 7.4 cents per sandwich is going to be our direct labor cost. Now, this is not the total amount that our sandwich is costing us. This is how much the labor is costing us. We still have to buy the bread and the lettuce and the cheese and the ham and the mayonnaise. So use a time study to help determine production and the cost of production of highly repetitive jobs.